Here we are discussing an important question from the chapter complex numbers. Question is, represent the complex number 5 minus I upon 2 minus 3I in the polar form. This form is called Cartesian form. The standard form of Cartesian form is z is equal to x plus iy. Okay, and we have to write this complex number from Cartesian form to polar form. And before writing in polar form, we have to convert this expression in standard form. This is called standard form of a complex number. Z is equal to x plus iy. Correct? So let us see the solution here. Here let us suppose z is 5 minus I upon 2 minus 3I, and this is equal to 5 minus I upon 2 minus 3I into, here we will multiply numerator and denominator by the conjugate of the denominator. Conjugate of denominator is 2 plus 3I. 2 plus 3I. Let us simplify it. Denominator is in the form of a minus b into a plus b. This is a square minus b square, 2 square minus 3I whole square, and numerator will be multiplied. So 5 into 2 plus 3I, that is 10 plus 15I, and minus I into 2 plus 3I, minus I into 2 is minus 2I, and here I into I is I square, which is equal to minus 1. So minus 1 of minus is plus 1. So this is equal to plus 3. And this is equal to 10 plus 3 is 13. 15I minus 2I is 13I. And denominator is 2 square is 4. I square is minus 1. So this minus becomes plus, and 3 square is 9. So we are getting z is equal to 13 is common in numerator, 1 plus I, and denominator is 13. 13 will be cancelled out. So we are getting z is equal to 1 plus I. Let us write it, relation number 1. This is the standard form of the complex number in Cartesian form. Okay. Now in polar form, let complex number z be r cos theta plus I sin of theta. This is relation number 2. Now comparing these two, we have to find here value of r and value of theta, and these values we will put in equation number 2, then we'll get the result. Okay, so comparing relation number 1 and 2, comparing relation number 2 and 1, r cos theta is 1. This is the real part of the complex number. R cos theta is 1. This is equation number 3. And comparing imaginary part, r sin theta is equal to 1. R sin theta is equal to 1. Equation number 4. Now squaring and adding relation number 3 and 4. Squaring and adding. Three and 4. We'll get r square common, cos square theta plus sin square theta, and then right hand side 1 square plus 1 square, that is 2. Here cos square theta plus sin square theta is equal to 1. So we are getting r square is equal to 2, and therefore r is equal to square root of 2. Okay. Now we have to find the value of theta. Here we are getting value of r. For finding value of theta, let us divide relation number 4 by relation number 3. So dividing 4 by 3, we will get r sin theta upon r cos theta is equal to 1 by 1, that is 1. R will be cancelled out. So we are getting tan theta is equal to 1 and 1 is tan of pi by 4. So by comparing tan theta is equal to tan pi by 4, we are getting theta is equal to pi by 4. So we are getting value of theta here. This is value of r. By putting the value of r and theta in relation number 2, we will get the answer. So therefore polar form of z is equal to r is root 2 into cos of theta means pi by 4 plus I sine of theta sine pi by 4. This is the answer. Very interesting, very simple. Hope you have understood it. Now we will see some more important questions. So remain in touch with this channel, with this video, and share this video with your friends also. Wish you all the best.